Hi, Eric.
Hey, how's it going?
Okay. I would like to serve as the MC for today's session.
Wonderful.
I can help field questions or respond to things in chat or whatever you like. I don't have a landing page for people, but I will, um, at the end of it, direct people to the VCO web page to see the other upcoming ones.
Yeah, I think so. I'll do the introduction and well, introduce the curriculum again, kind of go over the details, and then I wanted to leave uh, quite a lot, if not most of the time for Q&A, just so
Okay.
that it's a little bit more of a
Cool.
discussion.
Yep.
I'm like waiting for the snow to fall, but I think it's gonna miss us.
No, really? Wow. It's like 70 degrees here in upstate New York.
Yeah, it was 70 here. Well, not 70, but it was high 50s, I think low 60s like days ago, you
Yeah.
know.
And then it's
Just south of us, I think they're getting hammered. It was mostly just there's this like heavy band, and it
mm,
was just whether it was going to move a little farther north and hit the metro area, or it seems like it's dipping south. So our estimates yesterday,
button. And after the recording is processed, we'll be able to put it onto our website with the other instances of our virtual consulting office. So with that today, I will turn it over to Dr. Eric Shook at the University of Minnesota. He, with iGuide, is one of the co-leads of our education and workforce development team and has been working very actively on this Convergence curriculum for geospatial data science for the last couple of years, and we're grateful that he's able to give us an update today about its status and any questions you might have about it. So Eric, I'll turn it over to you.
yeah, thank you, Diana. So, yeah, Diana just posted it. I'll throw it in the chat one more time in case if anyone joined late. I made a public version of the slides that I'm about to present so that it's accessible to everyone in case if I advance the slides too quickly and you want to go back or race ahead, and just generally then they're open and available to everyone. So today what we're going to do is talk a little bit about the Convergence curriculum for geospatial data science. I actually want to spend the vast majority of the time in Q&A. So rather than kind of explaining the curriculum in gory detail for an hour, I actually would rather open it up and allow you to ask questions about the curriculum, how it could be used, how potentially iGuide can enable using parts of the curriculum in your classroom, in your out of class activities, if you do any sort of kind of training, if you do any sort of kind of public engagement. We've been trying to partner with other organizations, individuals who are interested in using curriculum materials for a variety of uses. As we'll talk about with the curriculum, it was really designed in a way to cross many disciplines and bring geospatial data science not just to the GIS crowd, which is kind of like the vertical silo of disciplinary expertise that I tend to sit in, but also lots and lots of other domains. So I'll give an overview today of the curriculum for those of you who are new to it, a kind of a reminder, and then we'll go over some of the components, some of the design. We'll look at it on the web page. We have, all of the materials are there available for free and are open. And then I will basically end the presentation and we're just open it up for a discussion. So if you have questions while I'm presenting, I won't watch chat, but I will come back to chat at the end. So if something pops up, I can always go back on slides and things like that. But mostly I'd like to open it up for Q&A at the end. So before we talk about the Convergence curriculum, I just want to make one shout out is that one of the other key activities that the Education and Workforce Development team in iGuide does is host an annual summer school. So for the third year in a row, iGuide is going to be hosting a summer school at the UCAR campus in beautiful Boulder, Colorado. August 4th through 8th, 2025. So this year, early August, UCAR campus in Boulder. We had a call for team leads, and now, excitedly, we have a call for participants. So if you know anyone who is an early career scholar, current PhD student, post PhD student within a couple of years of graduation, either as a postdoc or an early career instructor, faculty member, etc. Please send the call for participations to them, or if you're a faculty member, feel free to distribute it at your institution, in your departments. We have had a wonderful time with these summer schools in the past couple of years. We're really looking forward to the theme of spatial AI for extreme events and disaster resilience. So the call is open. The website's there. We can put it in chat, and of course, it's available online as well. So I just wanted to do that little shout out before we jumped into the curriculum, because these things are all very interrelated. But most of you probably joined to talk about the curriculum rather than the summer schools. So we'll kind of jump into it. And what I like to do whenever we talk about the curriculum is to kind of change the mindset a little bit. And I apologize if you've been to any of my talks in the past, because I introduce it in the same way, which really motivated the design and development of the curriculum, which is to recognize that in iGuide and other kind of convergent and interdisciplinary projects, one of the key goals is actually to get scientists and scholars from different disciplines to engage in the same problem. In doing so, what you have to do is bring kind of their knowledge and expertise over and kind of cross the disciplinary silos into kind of another knowledge domain in order to tackle the problem in a way that your maybe domain wouldn't have originally. And one of the challenges is that the traditional kind of models for training and education in universities kind of don't lend themselves to this sort of a format. So the traditional, what we call T model in university education, is that you have this kind of wide knowledge breadth. These are sometimes called liberal arts classes, kind of the gen ed, general education classes, where you just get, a little bit of a lot of different things. And then you pick a major, and your major is where you start to develop knowledge depth, right? So you get a little sprinkling of lots of different topics. You take classes from all around campus for your gen eds, and then you pick a major, and that's where you really start to kind of dig deep into one kind of knowledge space. So that's the model that's been working at many universities. Of course, as we start introducing kind of interdisciplinary work and different majors come up, we're very creative in university land, and we come up with what's called the pie model, where maybe you're a double major or you have a major and a minor, where you're developing kind of two legs of knowledge depth with that similar kind of knowledge breadth at the top. The problem with these models is that it's really up to the learner in order to make any sort of connections between those knowledge depths. Because if you are a major in GIS and you are a major in environmental sciences, It's not necessarily designed in the curriculum for an instructor to say, this is how GIS connects to environmental science. Now, naturally, you're going to have some examples where there is an overlap, but for the most part, GIS is designing for knowledge depth in GIS, and environmental science is developing for knowledge depth in environmental science. And this isn't something that we really wanted to do in the iGuide curriculum. So what we were really focused on is developing what we affectionately call the U model, where we do have that knowledge depth, but what we actually want to do is to do training and education, helping people build those connections, and not just at the top, because it's really easy to make broad examples of where GIS actually contributes to environmental science. Now environmental science contributes to GIS. That's kind of easy to do, but once you're kind of in the depths of the fields, you still want to see some of those knowledge connections. So this is one of the kind of core design elements that's a little bit different than some of the other curriculum models that you might be familiar with. So after lots of iterations and feedback, the history of which you can go into other talks that are available on the iGuide platform. I'm going to save you all of the history, and if you're really interested, you can check it out. There's a QR code. I'll post a link to it in just a second. And it has previous webinars and talks about how the curriculum was really designed. And the whole idea is that we wanted to support what we call multiple learner pathways, which means that if you are a social scientist, you will have perhaps a different pathway to engage this curriculum than if you were a computer scientist. Because the social scientist is going to come with their own set of background and expertise. So maybe a social scientist actually has significant training and education in something like ethics, but they might not have a lot of education and training in computing. Whereas maybe a computer scientist has a lot of education and training in computing, but maybe not so much in geospatial. So what they need out of this curriculum is actually different. So we want to recognize the fact that people from different disciplinary domains in different backgrounds are going to need something slightly different. So how do you actually design a curriculum that works for as many disciplines that can engage in geospatial data science as possible, and allow them to connect their existing knowledge or knowledge that they're building with all of the other topics that are relevant? So the way that we've designed this curriculum model is at the very bottom, we identified 5 foundational I'm sorry, 5 foundational knowledge threads. I had a little cough there. Ethics, analytics, geospatial computing, and visualization. This isn't to say that these are the only foundational knowledge threads in all of education, but for our curriculum model in the problems that we're focused on in iGuide, we identified these kind of 5 foundations as having things that are kind of isolated in a certain way, meaning that if you're talking about ethics, we have kind of unique ways of thinking about ethics, how we handle data with ethical approaches. Ethics has their own sets of methods as well as tools. And the same can be said about all of these foundational knowledge threads. So this is how we can basically build a foundation across all of these areas, and different people will need different amounts of education and training in those foundational knowledge threads coming from their own background. Then we go one step up and we get into what we call knowledge connections. And this is where we're taking 2 or more foundational knowledge threads and connecting them, and actually building curriculum that focuses on that explicit connection. So for example, if we take geospatial plus ethics, we have the knowledge connection of geoethics. Now, geoethics has elements of both, but it also has its own kind of focus and things that it's interested in. The same can be said with data mining or geospatial computing, etc. So we're designing the curriculum to actually make those connections and then make the materials available for anybody who uses them. Then we go one step up into an area that we call the knowledge frames. And this is where we're starting to introduce kind of cutting edge technology in the form of AI and different technologies that data science uses. And the reason why we call it knowledge frames is that we're using some of these technological components to kind of frame what it is that we're working on. So there's going to be elements of problems that we're not going to be able to solve or address when we're talking about geo AI. So we're kind of, setting up a bound of what we're trying to focus on. And what we can do is kind of build upon these knowledge connections, get into geo AI, get into geospatial data science, and then ultimately at the very top of our curriculum, we have what we call knowledge convergence. And the idea here is that then we can build curriculum around convergent problems. We have one example in the curriculum right now around aging dams, which has been a kind of a convergent problem that iGuide has been focusing on. And this is going to be where some of the new curriculum development is going to be focused, is showing kind of research-oriented real-world problems that can be solved with kind of convergent thinking. But we had to wait for some of the science to catch up so that we could build curriculum around it. Of course, happy to answer questions around the design and these sorts of things. But more interestingly, perhaps to many of you, is that we actually have curriculum for each one of these boxes. So I call them curriculum components. So if you're interested in having either a little or a lot of discussion around ethics, we actually have a web page for you that has curriculum around ethics, similar for data mining, similar for geospatial data science, etc. So I'll show you a couple of examples of that in just a minute. Um, so the focus here is really around connections. We spent a lot of time and then did following from listening sessions, did more feedback, more listening sessions, and really tried to design a way to help people connect what it is that they know, what it is that they're learning, and how they can kind of build that up into what we call knowledge convergence. How do we do that? We created a modular structure. So for each of those boxes that you saw on the previous slide, we have 3 levels of curriculum that we have available. So for every single one of those boxes, we have a 3-sentence description that takes about 30 seconds, where we define it. We give a key idea from it. So for example, what's a key idea behind GeoAI? And then one example, right? So this allows anyone to be able to quickly talk about any of these topics. And this is really necessary because when you're working in an interdisciplinary project, somebody might ask, what is geoethics? So, very quickly, you can read out 3 sentences and everyone gets a very top level 30,000-foot view of geoethics. If you want to go one step further, we have 3 slides. This takes, roughly, let's say 3 minutes in some sort of an education or training setting. Each slide provides a definition, provides an example, and then has some either kind of open kind of trigger questions or an open discussion that people can have around the particular topic. And then the meatier one, all the way at the bottom, is a 3-hour module. So the 3-hour module is where a lot of the curriculum development was happening because it takes a while in order to get all of these pieces in place. And the 3 hours are split up into a kind of 1-hour lecture with slides, a 1-hour hands-on activity that many of which use the iGuide platform for using things like Jupyter Notebooks, and then 1 hours of kind of reading and reflection. We have, pointers to open educational resources where learners can, read up on a topic before the lecture, and it might have some kind of discussion or questions. So this is kind of the modular structure that we designed the curriculum around. So not only do we have all of these components with all of their connections, for each one of them, we have 3 levels of curriculum development, depending on how in-depth you need to go. Because if you're a social scientist, you might not need 3 hours of discussion around geospatial computing. Maybe all you need, sorry, I'm going back and forth. I'm just trying to connect the slides here, but maybe you only need 3 slides. Maybe, if you're a social scientist, you just need a general awareness of what is geospatial computing. And, if you talk about what is geospatial computing, you give an example, you have, kind of a quick 1 to 2 minute discussion around it, you move on. That's sufficient for your style of learning because you don't have to be an expert in all of these components. The web page for the curriculum materials we'll throw into the chat as well, but is available where all of this stuff is there. This slide I'll go through quickly. This is a little bit just our efficient reuse of nesting the materials. So when we developed the 3 sentences, it became the introduction for the 3 slides. The 3 slides became the introduction for the three for the 1 hour lecture as part of the 3 hour modules. So the idea there was to just have this kind of consistent use of all of the materials and to be a little bit efficient in terms of the project. The other aspect of this that I kind of underlined here is that we used existing open educational resources when available. We really didn't want to reinvent the wheel if there was already high quality open educational resources available. So in a lot of places, the readings, some of the hands-on activities, some of the slides are already produced. So we were using those whenever we could. So this was kind of the idea. And then if we wanted to expand further, we can combine several 3 hour modules into 3 week units. Of course, we're also trying to build connections with the curriculum and other kind of education and training pieces. A huge shout out to a consortium that I'm involved with, which is the University Consortium for Geographic Information Science. They've developed the UC GIS&T body of knowledge. So this is kind of the GI science community's large body of knowledge. And the beauty of this project is that it actually becomes kind of some of the reading materials for a lot of the components. So we're trying to kind of build and bridge these connections so that the curriculum doesn't stand kind of outside in its own little island, but is actually kind of attached to some of the other fields that we're interacting with. So that's kind of a broad level overview. And for those of you, if we had anybody joining late, I wanted to kind of not focus a lot on the history and the depths of the curriculum. What I wanted to do is to give kind of a relatively quick overview of the design, kind of what's in the curriculum, and then largely open it up for Q&A so that if people have questions about how it can be used, where it could be used, maybe you want to contribute, of course, happy to talk about that. But what I really want to do is actually take a look at the curriculum itself. So if you click on this link, which I will toss in the chat real fast here, that way it's convenient for everyone. I'm not watching the chat right now, but I will go back to the chat once we get to the Q&A. If you navigate to that web page, I'll zoom in just a little bit here. What you will see is that same figure, except for it's color coded. And off to the right, you will see that the kind of edges of each of these boxes matches the color coding. So we have the foundational knowledge threads here, which matches here. We have the knowledge connections here with the red boxes matching here. We have the knowledge frames in the green boxes here. We have domain knowledge in the yellow box here, which I skipped over. But of course, one of the things that's really important when you're talking about GeoAI, geospatial data science, and convergent problems is the other domain knowledge areas. We've been building domain knowledge in several of the areas. We have some curriculum that's slated to be released in the domain knowledge areas right now, we have an entry starting with atmospheric sciences as well as urban studies. And then we have knowledge convergence with an example of aging dams. And another shout out that is not part of my figure here, but we also have a number of community contributions. So we have either community champions in iGuide who have actively developed curriculum material that aligns with kind of the design of our curriculum and shows examples of things like knowledge convergence. So we've had a number of different contributors, so Joe Holler and Peter Kedron made an entry with reproducibility. So we have the 3 sentences here on reproducibility. We have their 3 slides talking about reproducibility, showing the kind of definition. And then we have, kind of a key idea or what's it about. And then we have, kind of some discussion prompts. And anybody can take these 3 slides and throw them into an existing lecture, kind of a training, if you want to talk about the topic of reproducibility without, a lot of effort. And I think we can all agree that if you are an instructor or a faculty member or somebody who teaches, we're all limited in our time. So to be able to just have some curriculum materials that are just available, you can just snag them, toss them in, it's a fantastic way in order to do that. So all of these boxes have, different curriculum components. My favorite, of course, is geospatial computing. So I'm going to click on that. The reason why it's my favorite is because that's what I do. Uh, so since I have the mic, you all get to see my favorite topic. So you get to see the 3 sentences. We have 3 slides on geospatial computing with, a definition, kind of a key challenge, and then, a little quote and a little kind of open question that can be talked about in a class. And then importantly, if I scroll down, you can see the design of our 3-hour module is actually just a really flexible Google Doc where in the Google Doc, we have the materials. So the materials include 1 hour reading and reflection. So this is kind of the first hour of your module. And here I'm linking to GIS topics from the GIS&T body of knowledge, talking about the origins of computing in GIS&T, as well as GIS and parallel programming. So, this just kind of primes the readers and the learners with, a little bit of uh, jumping in. And then we have some kind of reflection questions or prompts describe the benefits of parallel programming that links with those activities. Then we have 1-hour slides. So if I click on this, it will link to our Google slides on geospatial computing. And what you'll notice is that the first 3 slides are the first 3 slides earlier, talking about our nested design. And then we talk about geospatial computing, sitting at the intersection of geographic information science and computational science. And then I talk about, a big picture introduction where we just walk through how the relationships between, researchers, cutting edge technologies and studying and solving geographic problems and kind of like all of the definitions and how that becomes geospatial computing. So I'm not going to go through, obviously, a 1-hour lecture, just giving you one example of what these curriculum materials look like so that when we get into the Q&A, you kind of see at least one working example. Obviously, it's all open, so feel free to click around and explore as much as you'd like. So that kind of was most of the introduction and overview. I'm happy adding detail, going back to what I talked about, jumping into a specific piece, because mostly what I want to do is make this time available for you all who graciously gave us time by joining this VCO. So, I want to basically give you the time to ask any questions that you have. I'll provide the best answers that I have for you. And if I can't get you the answer right now, what I will do, and this is being recorded, is I will follow up. And if it's specific to you, I'll send you an email. But if it's for a wider group, what we'll do is make it available on one of our web pages so that the whole community can benefit. Of course, we would like to acknowledge National Science Foundation and a number of other kind of collaborators, partners, team members in putting this all together. Because while I'm talking and giving this presentation, it certainly was not just me who did all of this work. So I just want to thank everyone for the time of listening just for this overview. And then what I want to do is stop sharing my screen here and then open it up for discussion, questions, etc. So I'm going to pause my microphone here and we'll open it up for anyone who's brave enough to unmute your microphone. And once I have a pause in questions, I'll start scanning through the chat if we had any open questions, or if Diana caught anything that we should address while I was chatting.
Thank you, Eric. Thank you very much for that overview. I think we kept up with putting fresh versions of links into the chat as people were arriving. I know I have some questions, but let's see what the audience might have. If you've
Hi.
unmuted yourself, yeah, please feel free to ask Eric a question.
Hi, Eric. Thank you for the informative presentation. I'm just trying to better understand what is considered convergence geospatial topic. So is something like, let's say, using remote sensing with irrigation or hydrological model to monitor irrigation. Is that convergence the same as remote sensing with crop models? Are these kind of things considered in the same scope, or are they different? Thank you.
Oh, that's a fantastic question that, probably takes an afternoon of debate across all of the researchers. So I'll do my best to not upset too many people, is how I'm going to answer this. So and maybe I'll even caveat in saying this is going to be Eric Shook's answer and not the official iGuide answer, just in case if I don't throw the umbrella to be broad enough. But the way that I would say we're talking about kind of convergent problems and convergent problem solving, convergent research, is when you really start to have to ask questions in a different way. And you have to start understanding in quite a bit of depth at least one other field. So, for example, if we're talking about, if we're talking about, let's say, crops and agriculture, and we're talking about things like nitrogen and fertilization. There's a lot of fields that look at that problem, whether you're in agronomy, whether you're in remote sensing, whether you're in, probably soils and, 10 other fields. I think when it becomes a convergent problem is when you're talking about looking at the cost of inputs, right? So you're talking about cost of fertilizer to the farmer, how that affects supply chain. And then you're starting to talk about when you dump that fertilizer into the soil and then it starts to have a positive impact on crop, that's great. But then it starts leaching into the water. So then you're talking about hydrology, right? And now you're talking about more than just the field, because once that gets into the first stream, then you're talking about everything downstream from that. So now you're starting to talk about water quality issues, not just at the soil and the stream next door, but as it starts to flow downriver, right? And then you start talking about things like, algal blooms and everything else downstream, but also all the people that drink that water or use that water recreationally. So then you're starting to introduce social science problems, right? And you're talking about, accessibility to clean water because maybe people in the polluted streams have a little bit easier access than the clean water so it becomes bigger. And I think what ends up happening is as scientists, we have to ask research questions. And the research questions that we ask have to be answerable by us and our team. So naturally, I'm a GI scientist. I'm going to narrow my topic until it hits a point where I can answer that research question, right? I'm not a social scientist, so there's a lot of social science impact that maybe my research has, but I can't answer that. So my research questions go zoop like this. I think what iGuide's really trying to do is to say there are these important problems, like aging dams is the one that I use because it's in the curriculum. When our dams start to age and maybe they're not maintained and they fail, what happens? Right? That's a big problem. Now, you can be a hydrologist and you can say, well, what happens is all the water flows down. But then, you have to talk about, flooding and how that impacts agriculture. It impacts, commercial operations. It impacts bridges downstream. It also impacts the communities of all the people who get flooded. So in order to really get at that question, you actually need to assemble an interdisciplinary team and they all have to start talking the same language, and that takes forever. So one of the things that we're trying to do with the Convergence curriculum is to allow a social scientist to come in and say, like, okay, you're talking about, things like hydrology and streams, and you're looking at that data. How do I learn how to be able to look at that data? Well, that ends up being a geospatial problem originally, because if it's all geospatial map data, then we have to talk about that. So that's my long-winded answer, trying to cast a pretty broad umbrella. And the big challenge and the whole purpose of the curriculum motivation is you have to get people to learn a lot, or sometimes just a little outside your domain. And that tends to be hard, especially after you're out of college. So I don't know if that fully answered it, but I at least talked a lot. So, we have that going on. That's your traditional academic answer.
Yeah, thank you. I think that's at least moved me a step further in understanding it a little bit. Thank you.
Eric is oh, I'm sorry, Shelby, please, yes.
Hi, I actually have a little follow-up question on what you just said. So you said after college, are you guys kind of creating this for more of like quick upskilling inside of the workforce, or who do you feel like your targeted learner is for your curriculum?
Yeah, so that has always been an ongoing struggle, and this is one that I actually fight very deeply into say, and I actually haven't said this in a public presentation, but I'll say it now. I think the target audience is anyone who is curious, and that's a pretty broad audience. And the reason why I say that is we ran last summer, in addition to the summer school, a mid-career training opportunity. And that was based off of feedback from actually many people when I was talking about the curriculum and pitching the summer school, of saying, once you're about 5 to 10 years post either master's or PhD, there's not a lot of training opportunities because most are really focused on early career. But then when you're talking about reskilling and upskilling, this becomes a challenge. So we actually had, it was a small group at the University of Minnesota doing a mid-career training focused around geospatial data science. It was a phenomenal group. And I think it was really helpful and useful. We've run a number of training exercises where it actually, the split of audience members, I would say, is, at least a third faculty members, instructors, people who either are learning it for themselves or maybe they're learning it so that they can teach it to their students. But you know, the curriculum is not just designed for undergraduate students. Part of it was also just training internal iGuide team members. So like we wanted to have something where it was like, okay, you just came onto the project, you need to contribute to aging dams. Like, here's some stuff that you can actually use to learn a little bit about what it is that we're talking about. Does that kind of open? Everybody pushes back against that because they say, oh no, you need to have like a much narrower scope. But
Right. Well, a
I'm
little
a
bit of
firm believer that if you're curious, whether you're middle school to mid-career, right? I'm a firm believer in this.
So yes, absolutely. A little bit of background on me. I'm actually an educational researcher and instructional designer with the Conrad Blucher Institute. So we're focused in geospatial science and land surveying. And so we have a really similar approach where we actually, you know, our big goal in our education initiative is to diversify and widen kind of the pipeline into the STEM workforce. And obviously that starts with K through 12 through higher education inside of Texas A&M University Corpus Christi, and then also supporting the current workforce. So that's why, as the education nerd in the building, I was curious.
Yeah, so gold star.
But no, so we have a similar
And
approach. We also think
as
it's
someone
frustrating.
who is, I'm not going to say equally invested, but because I work at an R1, so I have to be heavy on research. But as someone who tomorrow morning at 10:30 is going to be teaching an elective in front of 18 middle schoolers on geospatial technology, and we'll be doing that every week for the next 12 weeks. I do stand behind what I say because I'm a firm believer that you have to do it. So I'm actually developing curriculum material around geospatial technologies for middle schoolers that like I'm doing, so I can actually say something about it.
Awesome. Well, yeah, we'd love to, you know, chat with you guys more and see any way we can help or collaborate. So
Oh,
thank you.
absolutely. Yes, 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 yes.
Thanks, Shelby. Sean, you have your hand up.
Hey, Eric, good to see you. So, yeah, I like these little talks because it's a great way to learn about stuff rather than flipping through web pages. So your talk I kind of liken to the little way that you've structured all the topics in the curriculum. You know, here's the 3 sentences, here's the 3 slides, and maybe this was the 3 slides. But my question is, it kind of follows up on the last question. So coming back to more kind of standardized, you know, undergrad, what we do at the university, teach mostly undergraduate courses. Where, like, can you give examples of courses where this material has come in? So I'm you know, just for everyone else, I'm at UC Merced. I'm a computer scientist. I teach computer science courses, but I've always kind of thought about having a course on kind of computer science, whatever that means, right? And there's examples elsewhere. But kind of just examples of where the material that you have here has fit into undergraduate courses, not just that you've taught, but, you know, are there some that are more on the computer science side, some on the GI science side? Where does this curriculum kind of fit in undergraduate courses?
Yeah, so that's a important question. And I would say that this is now the key focus for the project. So of course, yeah, the curriculum fits into a number of my courses. There's a couple other probably more than a couple, but I'll say a couple just to always round down iGuide members who've brought these into their classes, some of which are active. Of course, as a large project, you always have some rotation of project members. And then some previous iGuide members have also taught the curriculum in their classes. Some of the delays of actually developing the version 1.0 of the curriculum was that we had some people who actually wanted to teach it and to use it in a classroom before we put it out publicly. So that actually was a little bit of a delay on a few of the curriculum components. So pulling from memory, I want to say the visualization was taught, of course. I actually, yeah, you said not my classes. I was going to say my classes have used a number of the geospatial, the computing, and the geospatial computing because that's what I teach.
But what, like, just again, your class, describing your class is fine. What department are your classes in, and what's their prefix? So I'm just trying to get some ideas of.
Yeah. So, so my class at the undergraduate level is Principles of Geospatial Computing. So,
And
so
what department is that in?
geography. Yeah.
Okay.
Yep. So right now I'm teaching Principles of Geospatial Computing at the University of Minnesota. It's in geography. It is 75 students online, taught asynchronously. The split of students it's about 55 undergrads, the rest grads. So I do a mixed class. And disciplines, I have no idea. It's definitely not all geography students. I can promise you that. I usually with the asynchronous, it's thrown me off a little bit more, but we pull from forestry, agronomy, environmental sciences, a lot of social sciences. We get some computer sciences. We have a data science major that's ramping up, so I get data scientists in there as well.
So it sounds interesting. It's not only applications people, but also you're mentioning some computer scientists and data
Yeah.
scientists. So
Yeah.
which is nice. Again, sorry to keep interrupting you, but I'm just trying to,
No, well, I think that this is actually you bring up a good point. And the reason why I wanted to switch this to Q&A is a legitimate question of like where can people use this and how can it be used?
and and examples, right? I think that's the other thing, where like what, just what where collectively has it been used, right?
Yeah. Well, and I will say I know the reproducibility from Joe Holler, Peter Kedron was actually pulled from some of the classes that they've taught.
Both
Urban,
also in geography departments.
they're also, yeah, they're in geography departments. I'm looking at.
So again, anything else, maybe anything outside of geography? Again, I'm just trying to probe, just trying to.
No, Sean, you're asking really good questions, and this is an area that we are early in the stages of getting some data from our evaluation and knowledge transfer perspective to see where, now that this has elements in all of its levels and it has been released in this 1.0, it's really time to see not just how it's just being used by University of Minnesota and Eric's classes, but what are some of the usage? And we have very little data on that at this point. And what we do have is just the beginning of things from access from website extent. We don't have a lot of follow-up information about who's going, how is it being used in classes, and when it's being used in classes, how effective is it? So thanks for just talking about that right now. It is something that iGuide, especially in its final year and a half right now, is thinking a lot about. How do we keep track of some of the metrics of usage beyond just website clicks?
Right.
Yeah, no, following on with Diana I'm not trying to escape that question. That's actually one of the reasons why we're doing these Q&As, is to see use cases and then kind of start that conversation. It was the final version of this just opened up maybe 6 months ago, sort of a thing, is finally when we got all the materials together. So now this is kind of a big focus, and then making changes to it as it goes. So
Eric, there are a couple questions. Debayan has one that he posted in the
yep, I
chat.
just noticed that in the chat. Let me.
And feel free if Debayan, if you'd like to just ask it directly to Eric. Yeah, feel free.
Sure. Sorry, I can do that. So just to follow up on your first question, right? I saw that there are many GeoAI applications, for example, convolutional neural networks for the streamflow predictions, which do have a very high accuracy. But when we incorporate this into the curriculum, I wanted to ask you how you design your curriculum in a way so that we do not promote like over reliance on the AI and encourage a little bit more critical thinking? And are we moving more away from, for example, properly defining what the physical process is and numerically modeling it, and to a sort of network or image-based AI and more focusing on the result? And we are if we are showing that to the students, or if we are promoting proper critical thinking into them.
Well, I will say that's probably a billion-dollar education question right there. So I'll split it apart a little bit, because some I think is education and training broadly, and then some is domain specific. So I'll start with the promoting over-reliance on AI as being incorporated into curriculum. I'm going to say that we actually don't know yet what the proper balance is. What I tell my students, both at the introductory level, all the way up to, I'm teaching a PhD seminar class right now in cyber GIS. So we just had a 3-hour discussion yesterday talking about this, because it was student selected papers and it was generative AI plus GIS. So we were literally talking about this yesterday. I think the challenge is that you can use AI to some degree to speed up either answering the question directly, which hampers learning in a lot of ways, right? Like you can use it for cheating and shortcuts. Like everybody knows this is a huge topic. You can also use it actually to facilitate learning, right? And I would say the facilitating learning is something that we actually don't have great structure, methods, approaches, things like that in education, because it's fairly new. We can draw analogies, right? So like math has been dealing with this for a long time with calculators, right? This is always the analogy that lots of people use, is like, well, why learn basic math when I can just say, 1 + 1 is equal to 2, right? Obviously, there's a lot of use for that. For programming, it comes into play. So I teach, people with zero programming experience how to program in Python to solve geospatial problems. In my class, I allow unlimited use of generative AI. There's no questions asked, there's no limitations, you use it wherever you want. Now, the trade-off with that is that I also have to design it such that you can't just use that all the way through and succeed. There's a variety of things that I won't talk about here because it's not necessarily relevant for iGuide, but it kind of goes to the question in terms of, I think we don't have full understanding yet in terms of where AI can be useful for learning. And I will say one of the first lessons that I teach in my advanced class is how to use AI for learning. So I actually show them a bunch of prompts on how you can have it help you explain topics and concepts, walk through examples. So, you can actually use it as a great learning tool, especially when the professor is busy or the TA is not available, or it's, 11 o'clock at night and your lab's due and you have a question, right? Like it's a little bit more accessible. Specifically on the domain side, when you're talking about process modeling rather than purely results driven, I actually think that's a domain specific question. And the reason why I say that is that if you're a social scientist, you don't have physics and process in the way that you do a lot of the engineering fields, right? So you don't hear social scientists asking that question because like people are too unpredictable to have like a physics-based approach that you would have taught like that anyway. Now, what they're grappling with is a lot of the ways that they assess learning is qualitative and essay based, and Gen AI is really good at that, right? So how do you actually evaluate a thinking process if Gen AI can do a lot of that? So so some of that's domain specific. I know I'm part of a panel and roundtable in like 2 or 3 weeks at University of Minnesota in the College of Liberal Arts, and these are all what's going to be discussed. In terms of iGuide, I think that one of the things that is actually critical is that you do have to make it available, right? So I think that one of the benefits from kind of a project like iGuide and some of the big funded projects that actually make some of the AI processing and learning how to do AI beyond just logging into ChatGPT, so that you can actually experience it, you can actually do it, you can actually learn how to do it. And with that comes a lot of better understanding, because I've been engaged in a lot of conversations about it with teaching and learning where it's pretty obvious that people haven't used it much, if at all, right? They talk about it in certain ways, and it's like, you've never actually used it in any way, shape, or form in depth. And that, I think, is unfortunate when we're talking about teaching, learning, and scholarship. So so I think one of the benefits of iGuide is that if we can actually have exercises that allows not only the students, but a lot of times the instructors to actually try it, and you can see what's going on, it actually answers a lot of those questions, because as soon as the instructors and the students start going with a results-driven approach and you start identifying all the edge cases, everyone starts to become critical, right? And that starts the process of like, what's the trade-off and everything else. And that's a fantastic, fantastic learning environment where the students or the instructors are raising the questions, right? Rather than, sage on the stage of explaining why it's bad, right? It's better to just experience it, see that it doesn't work in all the cases, and saying, well, what's going on here? So does that kind of make sense?
Yeah. I'd be really interested in a GIS programming course, how you make it proof of that, but maybe that's a discussion for another time. Thank you, though.
Oh, yeah. Yeah, a lot of my materials are actually open too. So some of them are available on the curriculum page, and then I have longer stuff that I share too. So yeah.
Eric, we had another question come in about some iGuide, any resources that we might have about pedagogical approaches in general, not just this content itself. And I know you've recently, you just reflected on a couple of things like this about that and what you do in your own classrooms. This might be an opportunity. I wouldn't say that we have anything specifically on the iGuide platform right now that fills that type of need, but I think it'd be a very interesting thing. We did have a webinar that looked at some geospatial approaches to teaching specifically a few weeks ago, and I'll put the link to that in the chat. But just thinking, I know we're at the top of the hour. Going forward, it might be interesting for us to schedule a VCO soon that had a pedagogical focus to it and talk about how we do some of these things in the classroom, get some different audience members to contribute their expertise and perspective as well.
Yeah. No, that's a fantastic. Yeah, we only have a minute.
Yeah, Shawen, you have your hand up?
Oh, yeah.
I call on the leader.
Thank you. Thank you very much. First of all, Eric, that was fantastic. I was thinking to directly respond to that pedagogical question raised in the chat. I think it'd be great to organize another VCO focusing on pedagogy. But just very quickly react to this point, as Eric summarized, we've been emphasizing this modular incremental learning processes from the pedagogical side, but also the experiential learning aspects. On the iGuide platform, Eric has pointed those learning resources to the iGuide platform without explicitly telling you it's actually on the iGuide platform. on the same platform, these curricular components and content are directly connected to other types of knowledge elements, such as Jupyter notebooks, data and code. They're interconnected in a way allows learners to explore these resources in an open, transparent, and reproducible way. So this is experiential learning and actionable knowledge elements through active exploration. Otherwise, it's very hard to assemble such resources in a cohesive, open way. That's what we're trying to promote, and we believe this is a important and effective way of conducting convergence learning. And that's a major pedagogical philosophical piece built into this convergence curriculum, and that's about the how, beyond the what, question posed by, I think, Don in the chat.
Yeah, thank you for adding that. And just a shout out, Diana beat me to it, that we actually had an earlier VCO last month, led by Babs Buttonfield from University of Colorado and Eric Money from NCSU, that did talk about some elements of pedagogy too. So if you're interested, they're both phenomenal. They were community champions for iGuide, but yeah, so a huge shout out for that session.
And Shawan, I think this would be interesting. There's the platform itself still has a lot of content in it, and there's still a lot of what there. And I think that an upcoming VCO session could really talk about approaches to integrating the use of the content that's at the platform within classroom contexts, including, you know, there are educational resources there, but how does it work to use all of these? What are the logistical processes and workflows of putting these into place in different educational learning environments?
Yeah, a great point. As Dong was asking, really focusing on how,
Yeah,
beyond just sharing the content
Right.
with some pedagogical principles and also guidance. That's definitely one very, I think, interesting VCO topic. Another one, I think, related to this as a VCO topic is how to contribute to the curriculum, right, from the broader community. That's another how, not necessarily how to use the existing content in the curriculum and on the platform at large, but how you as a community member and some of you ask questions, you know, how do you become influencer in this evolution of the curriculum? And the curriculum is created to help many influencers to not only adopt, but also to become creators of new content. And that's what we're really hoping to promote in the next few years. And I think we should host a VCO or a series of VCOs to invite those who either have contributed or have interest to contribute to participate.
a good idea.
Yeah, so well, and this was something Sean had mentioned too, just in terms of questions, and Shelby touched on it in terms of, yeah, examples and where and how and what's the level of learner and where can we see examples of it. So so thank you everyone. Know that your comments are not going into a void. So we actually meet, the Education Workforce Development team meets regularly. So we'll actually be taking these notes, discussing it within the team. Just like everybody on the call, everyone's always busy. So it does take a little bit of time to actually get the results from the discussion, but we'll be taking all of this feedback. So really, kind of thank you, because everyone's time is very precious right now. And the fact that you were brave enough to comment and unmute microphones and everything else is just greatly appreciated. If you have any other feedback, all of the links are there. Our contact information is open. send us an email. And if you're interested in contributing or have further questions, feel free to reach out.
Thank you.
Thank you again, Eric. Thanks very much to those contributing. The recording of this will be up soon. And I'll quickly put the iGuide, see if I quickly do it. The list of other upcoming VCOs. iGuide. Shoot, I should see it. Let's see if this gets it. So that we could let you know about other things that we have coming up. We try to do these on a weekly basis, informal opportunities to learn. Oh yeah, good. Thank you, Anand. So you got the link there. To learn more about the other upcoming topics, we will take a week off next week when many people are at the AAG in Detroit, and start up again after that in April with a fresh set of topics. There'll be more up on the website soon. Thanks again, everyone.
Thank you very much.
Bye.
Take care, folks.
Thank you, everyone.
Thanks, Eric.
Well done. Thank you.